mission. I hope you all got drinks and food and found a place to sit.
And beer.
That goes under drinks.
I might have already had a
special category.
Yeah.
But yeah, I am Sinclaire Manning, aka Major Merger.
I am Dr. Brian W. Mulligan, also known as AstroBit.
And we're here to present you this month's top news stories in astronomy.
All right, so first up, OSIRIS-REx has arrived at its target, the asteroid Bennu, on December 3rd. Since then, the mission has been in what's called the preliminary survey phase, where the spacecraft kind of maneuvers around nearby the asteroid, taking a series of images, kind of producing initial maps, getting a general map of the surface, searching for any plumes that are coming out of the asteroid, and identifying any possible tiny little satellites that might be orbiting it. So far, no discoveries on satellites, but you know, keep your eyes posted. Following this phase, OSIRIS-REx is going to get increasingly higher resolution maps of the surface and taking spectra of this asteroid to help composition. After all the mapping is complete, the most exciting part of this mission is that it's going to get close enough to touch the asteroid. It's actually going to deploy, as you can see in the picture on the side here, it's going to deploy an arm with a sampling thing on the end that touches the surface and kind of sucks up all the rocks and dust and whatever is on the surface of that asteroid, and then bringing that sample back, putting it into a container, coming back to Earth, and dropping it down to Earth in 2023. It's pretty cool. First time we get an asteroid sample. And then in addition, this is also pretty interesting, on December 10th, the spectrometers on board the on board the spacecraft were already taking data. They found evidence of molecules called hydroxyls. The presence of these molecules indicates that there must have been liquid water that interacted with the rocks on the surface of this asteroid at some point in the past. Now, asteroid Bennu itself is too small to have ever had liquid water on it, but we think that it came from a much, much larger asteroid or maybe small planetesimal or something like that in the past, and that must have had liquid water on it. So that thing eventually got broken up, the asteroid's there, and now we found the evidence of the liquid water elsewhere in the solar system through this spectrometry. It's pretty cool.
Nice. All right. Yeah. Anyone alive to see Voyager 2 launch? You don't have to date yourself if you don't want to, but I think it's cool. But so on December 10th, the Voyager 2 spacecraft made its grand exit from our solar system and entered interstellar space. Yeah, that's pretty cool. So Voyager 2 launched way back in 1977, and as I know, I'm sorry. But it has since spent more than 4 decades exploring our solar system, most famously becoming the only probe ever to study Neptune and Uranus during planetary flybys. So now it has joined its predecessor Voyager 1 beyond the bounds of our sun's influence. So Voyager 2 is the only spacecraft to have visited all 4 gas giant planets, so Jupiter, Saturn, Uranus, and Neptune. It discovered 16 moons, as well as phenomena like Neptune's transient great dark spot and the cracks on Europa's ice shell. So scientists use what is known as the heliopause to mark where interstellar space begins. It is the edge of the heliosphere, which is this light blue region on this graphic here. So the bubble is created by solar winds of charged particles flowing out from the sun and influencing the environment within the solar system. And beyond the heliopause, spacecraft fly through many more cosmic rays, which are much higher energy particles. So there are 2 instruments on board Voyager 2 to track these particles. And so the transition from mostly lower energy particles to nearly none of them, and then combined with the surge of cosmic rays, tells scientists that the probe has crossed the heliopause. So luckily, there's no need to say your farewells to Voyager 2 just yet. The spacecraft will continue collecting data until its plutonium power supply runs out sometime after 2025. So it still has many more years to go. It's not even in its prime yet. It's just
But that's
going.
so soon. That's so soon. It's lasted, 40 years now?
Still kicking.
Yeah. All right. So also in our solar system, still within our solar system, the InSight lander, of course, successfully landed on Mars, on the surface of Mars on November 27th. The mission's main goals are to gain a better understanding of the interior of Mars. This is the first focused study on the interior of Mars. It will do this by precisely measuring the rotation and wobble of the planet, and using seismometers to detect earthquakes, and then using a Marsquakes, thank you. I have that on the paper, I swear.
Wow.
Marsquakes.
I think it's time to turn in your badge, Brian.
I need another drink, I think. That'll help. Marsquakes. And then finally, using a heat probe to measure the temperature inside of the planet. So this is kind of cool, and it also feels like destructive and mean. The heat probe is going to be hammered into the surface to a depth of 16 feet. That's deep enough to figure out whether Mars is being heated by radioactive elements in the interior, much like Earth is, or if Mars is simply cooling from its formation 4.5 billion years ago. Data has already been received from the onboard seismometer, which you see in the like squiggly red and yellow and blue graph over here. The squiggles that you see here are purely due to wind that's hitting the spacecraft, mostly its solar sails, pushing and jostling it around. In the next several weeks, the seismometer and the heat probe are going to be placed onto the surface of Mars. First, there's going to be a whole lot of imaging of the nearby region to make sure that they, don't set it down on top of a rock. Goes like this. That would be bad. So all science operations should start within the next 3 months or so, and then the mission's going to continue for the next 2 years.
All right, so we've had a few talks about exoplanets here at AoT, and astronomers have cataloged nearly 4,000 exoplanets in orbit around distant stars to date. However, there's still a lot we don't know about the birth of planets and the precise requirements needed to create a wide array of planetary bodies that we've uncovered. So to help with this, a team of astronomers has conducted ALMA's first large-scale, high-resolution survey of protoplanetary disks, which are the belts of dust and gas around young stars. So this survey is known as D-SHARP, which I think is a pretty solid acronym. We come up with some pretty crappy ones.
Can anybody sing that for us?
yeah, who knows what D-SHARP sounds like. But it stands for the Disk Substructures at High Angular Resolution Project, and it has yielded some absolutely stunning images of 20 nearby protoplanetary disks, which you can see here. So ALMA was able to distinguish features as small as a few astronomical units, or the distance from Earth to the Sun. Features like concentric gaps and narrow rings are common in nearly all the disks where planets are forming and carving out these rings of space as they accrete the surrounding debris. And in some cases, large-scale spiral patterns and arc-like features are also present, which are kind of hard to see here, but like the one at the top, like third on the top row, that one kind of has an interesting spiral pattern there to it. But yeah, so these disks and gaps appear at a wide range of distances from their star, from about a few AU to more than 100 AU, so over 3 times the distance between the Sun and Neptune. Now, if you want to learn more about planet formation and these super cool images, I just found out very recently that next month we'll be having a talk from our own UT postdoc Ben Toffelmeyer, who's going to be talking about exactly this and planet formation. So please come back next month if you want to hear about it.
All right, so this is, for me personally, is the most exciting story of this month. Supernova 2018 OH, our exciting naming scheme. It was discovered on February 4th, 2018. It's located in this, excitingly named galaxy UGC 4780. But the exciting thing is that this supernova occurred in a spot that the Kepler spacecraft was looking at the time. So we got very, very, very high frequency data, high frequency imaging of this supernova. So we're able to watch the supernova grow brighter in the first few weeks after it exploded. Normally, when we use ground-based telescopes to look at supernova, ground-based telescopes, we look at maybe 10 supernova a night or something like that. we don't really sit there and keep pointing at the same one. So the fact that the Kepler was looking at this one was really exciting. What's most exciting about this is that when we see a supernova, we want to know what the area around the supernova looks like. Whether especially for these particular types of supernova, this is a type 1a supernova, we don't know exactly the circumstances under which they explode. We've got a general picture, but we want to know exactly what's around it. So is there a companion star? Is there gas or dust immediately around it? We're still trying to figure that out. So the fact that Kepler was looking at this, and we were able to capture images every 30 minutes after the explosion, gave us a lot of information about what the environment immediately around the supernova is like. So this one we found that the rise of the brightness is not exactly what we have been generally saying that these occur, and it tended to be a lot hotter than we expect it to be in general. Now these are all predictions that have generally been made in terms of the supernova interacting with either a star that's right next to it that was feeding material over to it, or gas and dust that was surrounding the star just prior to the explosion, which is actually exactly what I studied. So this is the best evidence that we have so far that these stars, when they explode, have a companion star or something right next to them that's feeding into it and providing the material that's required to get the star to the point of explosion. So this is our best evidence to date. We're really, 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 really excited about this one.
That's coming from a supernova expert,
Yeah.
so believe him when he says that. And last up, we have our astronomy not in the news segment. So maybe something that didn't get as much press as it should, although looking back on it, I feel like this is kind of a big deal. So maybe the news cycle is just a little slow to catch up. But anyway, so an international team of scientists has discovered a new galactic neighbor that they are calling Antilla 2, or ANT2 for short. So ANT2 is a dwarf galaxy unlike any previously detected. Its area is similar to the Large Magellanic Cloud, or the LMC, which is the largest satellite of the Milky Way. And it is about a third of the size as the Milky Way, but it contains about 10,000 times fewer stars than the LMC. So this relatively small number of stars spread across this large of an area causes ANT2 to appear extremely faint, which you can kind of see in this illustration. That's the reason why I drew this red circle around it.
Everybody obviously sees the galaxy there, right?
Yeah,
Raise your hand.
Right, I said that. Its faintness, along with the fact that ANT2 is partially hidden behind the bright disk of the Milky Way, made it much more difficult to detect. So ANT2 was discovered amongst the data released from the Gaia satellite, which you heard a lot about in the first talk, particularly the precisely measured velocities of individual stars and the catalog of variable stars. So within the data, astronomers were searching for clusters of RR Lyrae, which are a type of variable star commonly found in dwarf galaxies. The team discovered a small group of these stars clumped together in three-dimensional space, and then selected all kinds of other stars with similar velocities and positions, and revealed the faint signal of ANT2. So the observations that ANT2 is huge but incredibly faint, meaning it has a very small stellar mass, suggests that the density of dark matter is extremely low. And its unusual nature may point towards exciting new evidence for non-standard dark matter theories. Maybe our next speaker can debunk this or say otherwise, I don't know. Though there are other possible explanations as well. We don't have to blow up our cold dark matter scenario. But either way, ANT2 may be the first of a whole new population of these very faint galaxies.
Pretty cool.
Yeah.
All right, well, thank you very much.
That's all for us.
This is Astronomy News for December 2018. Enjoy the rest of the show.
See you next month.